Welcome to our module on Python data structures. We'll explore how Python helps us organize and manage data effectively. These structures are fundamental for organizing and managing data efficiently within your Python programs. Let's begin with Python lists, one of the most fundamental and widely used data structures. Lists are incredibly versatile and dynamic sequences, perfect for many programming tasks. First, lists are mutable, meaning their contents can be altered after they are created. Yes, elements within a list can be changed, added, or removed even after the list has been defined. Next, lists are ordered, preserving the sequence in which elements were inserted. This means elements maintain their insertion order and are easily accessible using numerical indices, starting from 0. Lists are also heterogeneous, a powerful feature for mixed data storage. They can store different data types simultaneously, like numbers, strings, or even other lists, all in one collection. Finally, lists have a dynamic size, adapting to your program's needs. This means they can grow or shrink as needed, adding or removing elements dynamically during execution. Now, let's dive into manipulating Python lists. Mastering these operations is key for effective data management. These essential operations are fundamental for efficiently handling and organizing your data in Python. Let's start with how to create lists and access their individual elements. Lists are defined using square brackets, and elements are accessed using zero-based indexing, like my list at index 0. This code snippet shows creating a list, and then printing its elements at index 0 and index 2. Next, we'll look at how to modify existing elements and add new ones to your lists. Since lists are mutable, you can change elements by index, for example, my list at index 1 equals 10, or add elements using the append or insert methods. Here, we modify an element, append to the end, and insert at a specific position, then print the updated list. Finally, let's explore how to remove elements from a Python list. Elements can be removed by value using the remove method, or by index using the pop method, which also returns the removed item. This code demonstrates removing an element by its value, then using pop to remove the last element and store it. Beyond lists, Python offers other distinct data structures, tuples and sets. These structures serve specific needs, each with unique characteristics that make them suitable for different scenarios. Let's first explore tuples, which are quite similar to lists in some ways. Tuples are ordered collections, just like lists, but they are immutable, meaning their contents cannot change. Similar to lists, elements in a tuple are accessed by their index, maintaining their insertion order. You define tuples using parentheses, making them easy to distinguish from lists. Now, let's look at sets, a very different kind of collection. Sets are unordered collections, and critically, they only store unique items, automatically removing duplicates. Because they are unordered, indexing is not supported with sets. You cannot access elements by position. Sets are typically defined using curly braces, or by using the set function. Today, we're diving into working with tuples and sets, two fundamental data structures in Python. We'll explore their essential methods and operations, understanding how to effectively use them in your code. First, let's discuss an important characteristic of tuples: their immutability, which defines how they can be used. Remember, tuples are immutable. Once created, their elements cannot be changed directly. Concatenation, however, forms a new tuple. Here, we see that attempting to modify an existing tuple element will raise an error, while concatenation creates a new one. Next, let's look at how to add and remove elements from sets, which are mutable and dynamic. You can add single elements using the add method. To remove, use remove, which errors if not found or discard. This code demonstrates adding an element with add, removing with remove, and safely discarding with discard, even if not present. Sets are also powerful for mathematical operations, allowing you to combine and compare collections of data. You can perform union, intersection, and difference operations to find combined, common, or unique elements between sets easily. Here, we calculate the union to combine elements and the intersection to find common elements between two sets. Now, let's explore Python dictionaries, a highly versatile and important data structure. They are essentially about mapping unique keys to specific values, providing efficient data retrieval. Dictionaries are built upon the concept of key-value pairs, where each unique key points to a specific value. You store data as unique keys mapped to their corresponding values, making data access very intuitive. Traditionally, dictionaries were unordered, but in modern Python, they maintain insertion order. While older Python versions didn't guarantee order, Python 3.7 and later preserved the insertion order of elements. Dictionaries are mutable, meaning you can change their contents after creation. Their contents can be easily added, updated, or removed, making them flexible for dynamic data. A crucial rule for dictionaries is that all keys must be unique. Indeed, each key within a dictionary must be unique, preventing any ambiguity in data access. The primary way to interact with a dictionary is by accessing its values using their keys. Values are retrieved very efficiently by using their associated unique keys, ensuring quick data lookup. Let's delve into how we can effectively manage elements within Python dictionaries. We'll start by understanding how to create a dictionary, initializing it with key-value pairs. Next, we'll learn how to add new key-value pairs to an existing dictionary dynamically. Then, we'll cover how to update the value associated with an existing key in your dictionary. After that, we'll see how to access a specific value using its corresponding key efficiently. Finally, we'll explore methods to remove a key-value pair from your dictionary when it's no longer needed. Moving on, let's explore Python strings, which are fundamental for handling text data. Strings are Python's fundamental data type for representing and manipulating sequences of characters or text. You can create strings by enclosing characters within single, double, or even triple quotes for multi-line text. Indexing allows you to access individual characters within a string using their zero-based positions. Slicing lets you extract specific substrings by providing a range of indices, defining a start and end. Concatenation combines two or more strings together into a single, longer string using the plus operator. Repetition allows you to create a new string by repeating an existing string multiple times using the asterisk operator. All right, let's wrap up our discussion with a quick summary of what we've learned today. Here are the key takeaways focusing on the fundamental Python data structures we explored. Remember, lists in Python are ordered, mutable, and can hold different types of items, making them very flexible. Tuples, on the other hand, are ordered sequences but are immutable, meaning their elements cannot be changed after creation. Sets are unordered collections, useful for storing unique items, and they are mutable, allowing additions and removals. Dictionaries store data as mutable key-value pairs, providing efficient retrieval using their unique keys. Strings are immutable sequences of characters, specifically designed for handling and manipulating text data effectively. Ultimately, selecting the appropriate data structure significantly enhances your code's efficiency, readability, and overall clarity.